For today's lesson, the first thing I'm going to do is build the unit circle. You all have familiarity with the unit circle from Algebra 2. What I want to do is emphasize, well, why is it what it is? Because the better you understand how the pieces fit together, the more sense you'll make of it when you have to use it. So the first thing I'm going to do is label all the angles in standard position. So standard position means that the positive x-axis is our initial ray. That's 0 degrees. And then we're going to have 30, 45, and 60. The three special angles from our special right triangles are the three angles that are in the first quadrant of the unit circle, which is why we reviewed those three special right triangles before we got to this unit here. Then straight up would be 90 degrees. And then what I'm going to do is I'm going to emphasize reference angles here. This angle over here has the same reference angle as that guy, which means if that's 60 degrees, this is 60 degrees away from the closest x-axis, makes it 120. 45 degrees away from there makes this 135. 30 degrees from there makes that 150. Straight angles 180. 30 degrees past is 210. 45 degrees past is 225. 60 degrees past is 240. All the way around to here is 270. 60 degrees away here is 300. 45 degrees away there is 315. 30 degrees away there is 330. All the way back around to one full circle is 360 degrees. Okay, now marking those off in radians. 90 degrees is pi over 2. 180 is pi. 3 pi over 2. And then all the way around is 2 pi radians. The quadrantal angles, the rotations that land on axes, those are ones you should know by just memorizing. They're important facts that are key to this class. If you forget, if you want to go from degrees to radians, you're multiplying your degree number times pi over 180. Okay, the first quadrant, those are ones you also should know off the top of your head. If you don't, again, you can use the conversion formula for each one of these, which is right there. 30 degrees is pi over 6. This is pi over 4. This is pi over 3. All right, now, the rest of them, maybe you don't know off the top of your head, but this is a way that you can get them. 120 is 260, 2 pi's over 3. 135 is 3 45s, 3 pi over 4. 150 is 5 30s, 5 pi over 6. That one we already addressed. 210 is 30 degrees away from that axis. So you go to the 30 degrees here as your reference. 210 is 7 30s, 7 pi over 6. 225 is 5 45s. 240 is 4 60s. This one we already got. 300, that's 5 60s. 315, that is 7 45s. 330 is 11 30s. Okay, so that's one way you can identify the rest of the angles in a unit circle in radians working off the first quadrant. Okay, something of note that's going to be useful with later problem solving. If you notice all the angles that have a 30-degree reference angle, the denominator is a 6. All the angles that have a 45-degree reference angle, the denominator is a 4. All the angles that have a 60-degree reference angle, the denominator is a 3. So when we do some problem solving stuff, that's going to be a useful observation. All right, now unit circle. The word unit refers to the fact of 1 in general. Specific to the circle, it's a radius of 1. So what we're going to do is label all these points going around using the fact that the radius of the circle is 1. Well, the easiest ones to start with is that's the point 1, 0. That's the point 0, 1. That's the point negative 1, 0. That's the point 0, negative 1. Now what we have to do is hit all these other ones that are out in the quadrants. Okay, drawing this by hand, this picture is going to get very, very muddled. So what I'm going to do is the little derivations I'm going to do off on the side. So the first thing I want to concentrate on is that point right there. What are the coordinates of that point where that 30-degree angle in standard position intersects the unit circle? So that representing 30 degrees means that this is a 30-degree angle in there. What I'm going to do is box this in to form a right triangle. So this right here is our triangle of interest. What we have is a 30, get rid of that there, it's a little confusing at this point, 30, 60, 90 right triangle. We know that the radius of this circle is 1, so that makes the hypotenuse 1. Now from geometry and from a full day of review and on a unit test, we know that if you have any one of the three sides of a 30, 60, 90, you can find the rest. Cut that in half to get the shortest side, multiply by root 3 to get the hypotenuse. So that makes the coordinates of that point right there, root 3 over 2, comma 1/2. So I'm going to add that to this. And now I'm going to do this point right here. Again, it'll get really muddled, so I'm going to do it on a clean one. This point right here represents that 45-degree angle in standard position. So I'm going to box it in, and when we box it in, we're always going to the closest x-axis. The closest x-axis because that's incorporating the whole idea of the reference angle thing that we talked about a lesson or two ago. So that makes this a 45, 45, 90. Because the radius is 1, because it's a unit circle, that's the hypotenuse. If we know the hypotenuse of a 45, 45, 90, we're dividing it by root 2 in order to get the two legs. That rationalizes to root 2 over 2. Whatever one leg is, the other leg is the same. So the coordinates of that point are root 2 over root 2. Go back to this one. Fill that in. Now we're on to this point right here. I'm boxing it in to the closest x-axis. We always go to the x-axis because of the whole reference angle thing we talked about. We've already identified that this is 60 degrees. That makes this another 30, 60, 90 with a different orientation. Because it's a unit circle, the radius is 1. That's the hypotenuse of a 30, 60, 90. We cut that in half to get the shortest side, multiply it by root 3 to get the middle side. That makes the coordinates of this point 1/2 root 3 over 2. Okay, now, you can fill that in here. So now we have the three special angles in the first quadrant labeled on a unit circle. Now we can just use symmetry in order to fill in everything else. If we take all of these guys and reflect them over the y-axis, it changes the SIGNS's of the x's. So this has the same thing over here, except the x-coordinate is negative. This is the same thing over there, except the x-coordinate is negative. This is the same thing over here, except the x-coordinate is negative. If we reflect it down this way, reflecting over the x-axis changes the SIGN of the y's. So this reflects there, same pair of numbers except the y is negative. This reflects there, same pair of numbers except the y is negative. Same story here. Then to get the last quadrant, we could reflect this way or reflect down, produces the same result. So a completed unit circle with everything filled in looks like this. So we have all of our angles measured in degrees, 0 to 360. All of the angles, or the special angles, measured in radians, going all the way around. The coordinates of every point labeled. All right, so what is the significance of what's happened here? Why is this important to us? What I'll do is a quick little example to illustrate this. This is our angle of interest right in there. Okay, this length of the triangle here is root 3 over 2. That is 1/2. The radius is 1. So the sine of that angle, opposite over hypotenuse, 1/2. Cosine of that angle, adjacent over hypotenuse, root 3 over 2. So this point right here tells us the cosine and sine of that angle. Once you know cosine and sine, you can get the other 4 trig functions. The reciprocal of cosine is secant. The reciprocal of sine is cosecant. Tangent is sine over cosine. Cotangent is cosine over sine. So if you know these two, you can get the other 4. So one of the things you can do with the unit circle is you can get the exact value for any trig function of a special angle, or a special angle, or any angle that's coterminal with a special angle. So that's the first thing we're going to be doing with the unit circle in terms of a problem-solving situation. Looking for my examples here. Hang on a second. So, these are some typical types of things that you're going to be asked to evaluate. The first one, the tangent of 2 pi over 3. So what you're going to do is you're going to find 2 pi over 3 on the unit circle. There it is right there. Tangent is sine divided by cosine. That's the cosine, that's the sine. So sine divided by cosine. Negative root 3. The tangent of 2 pi over 3 is negative root 3. Reviewing some other stuff that we've talked about. We know all seniors talk constantly. All of your trig functions are positive in the first quadrant, sine and cosecant in the second, tangent cotangent in the third, cosine secant in the fourth. So if 2 pi over 3 is a second quadrant angle, the only trig functions that are positive in the second quadrant are sine and cosecant. The fact that tangent is negative makes everything fit together. Okay, next example. The secant of negative pi over 6. Well, negative pi over 6, as is, isn't labeled on a unit circle. Negative pi over 6 is rotating down this way. Pi over 6 in a negative direction. So it's coterminal with this. If it's coterminal with this, that means it shares the exact same values of its trig functions. So finding the secant of 11 pi over 6 is the same as finding the secant of negative pi over 6. They're coterminal, they have the same values. Secant is the reciprocal of cosine. So the cosine is the x-coordinate, root 3 over 2, flip it, 2 over root 3, rationalize. 2 root 3 over 3, that's the secant of negative pi over 6. Okay, next one, negative 5 pi over 6. Again, that's not labeled as is on the unit circle. So we need to find out what's coterminal with negative 5 pi over 6. Well, a positive 5 pi over 6 would be rotating that far in a positive direction. If we go that far in a negative direction, it lands it here. Now, one of the things I mentioned earlier that's good to know is if that's got a 6, this has got a 6. We know that that reference angle has to be the same as that reference angle. Anything that has a 6 on the bottom has a reference angle of pi over 6. So back to this problem, the sine of that is going to be the y-coordinate, negative 1/2. All right, that one unit circle is kind of marked up. I'll get a new one for the next couple of examples. So, recapping. One of the things the unit circle does is it gives us a reference tool for evaluating functions that look like this. Any trig function of a special angle or an angle that is coterminal with a special angle can be evaluated by using this tool right here. So cosecant of 11, can't see that, I'm sorry. Cosecant of 11 pi over 6. So we're going to locate 11 pi over 6 on a unit circle. It's right there. Cosecant is the reciprocal of sine. The sine of 11 pi over 6 is negative 1/2. That's by definition of what a unit circle is. That's the cosine, that's the sine. The reciprocal of negative 1/2, negative 2. All right, sometimes it takes more than one rotation in order to locate that point of interest. 21 pi over 4. That's the same as 5 1/4 pi. For visualization purposes, some students find it easier to think of it as a mixed number pi. It helps you locate it. So in this case here, going in a positive direction, that's 2 pi, that's 4 pi, that's 5 pi, a 4th pi lands here. So 21 pi over 4 is coterminal with 5 pi over 4. That means they share the exact same values for their trig functions. The cosine is the x-coordinate. All right, last example, the cotangent of 3 pi over 2. Okay, 3 pi over 2, that's labeled on a unit circle. It's right there. Cotangent is cosine over sine. The cosine is 0. The sine is negative 1. The cotangent of 3 pi over 2 is 0. All right, what if this was the tangent of 3 pi over 2? If it was the tangent of 3 pi over 2, it would be sine over cosine, which would make that negative 1 over 0. That would be undefined. The zeros are possibilities when you have a quadrantal angle. Oops, sorry, I didn't see that. The zeros are possibilities when you have quadrantal angles. So if you have a quadrantal angle, it means when you do the rotation, you land in one of the axes, it's possible that the 0 could be on the bottom of the fraction, which means it's possible that that function is undefined. So one particular example of that is the tangent of 3 pi over 2 is undefined because the 0 is on the bottom of the fraction. All right, as far as the skill set that you need to have for today, this is it. We went through why the unit circle is what it is. There are things you can do with the unit circle beyond what we've covered today. But for today, the skill set is, can you use this unit circle in order to evaluate trig functions that look like this?